Hello, so today we will talk about problem number 21. So if you see the mass spectrum of this compound molecular formula is given already. So our first task is to find out hydrogen deficiency index, which is known as HDI. So what's the formula to find out hydrogen deficiency index? 2C plus 2 plus number of nitrogen atom minus number of hydrogen atom minus number of halogen divided by 2. So this is the formula to find out hydrogen deficiency index. Simply, we have to put the value to remain as it is. How many carbon are present in this compound? 4 carbon plus 2 according to the formula. How many nitrogen? There is only one nitrogen. How many hydrogen? 9 hydrogen. Is there any halogen in this compound? No halogen. So 0 divided by 2. So let's put the value 4 plus 2, 8. 8 plus 2, 10 plus 11. 11 minus 9 divided by 2. So 2 divided by 2 is equal to 1. It means this unknown compound contains one double bond. So purpose of calculating hydrogen deficiency index is to find out number of pi bond, number of double bond in this unknown compound. So there is only one double bond in this compound. Now look at the IR spectra of this compound. If you look at the IR spectra of this compound, you are getting a broad peak over here. Broad peak roundabout in the range of 2500 to 3100. So whenever you are going to see a peak like this, then this is a confirmation this unknown compound contain carboxylic acid. Carboxylic acid OH appear in this range. So it means this unknown compound contain carboxyl group. So degree of unsaturation is 1. So it means this compound contains this group. Okay, now let's see the carbon 13 NMR of this compound. If you look at the carbon 13 NMR, carbon 13 depth is showing there are all of the signals are CH2, CH2, CH2. But if you look at the proton decoupled spectra, the proton decoupled spectra is showing this unknown compound contains 4 types of a signal, 1, 2, 3, and D. What about this signal? This signal is quaternary carbon or carbonyl carbon appear in this range. I told you last time as well. As the IR is showing, carboxyl group is present in this compound. So carbonyl group, because this carbon does not carry any hydrogen, so it will appear in the range of 170 to 220 roundabout. So carbon 13 NMR is telling us this unknown compound contains 4 different types of carbon. Okay, now let's move towards C4H9NO2. C4H9 molecular formula was C4H9NO2. So molecular formula is telling us a unknown compound contains 9 hydrogen. 9 hydrogen. So now if you see here is a note is given, there are 3 protons with exchange with D2O solvent. So there are 3 protons in this compound which are connected directly with heteroatom. Now 2 types of heteroatom are present in this compound. One is nitrogen, other one is oxygen. So it means the 3 protons will be connected directly with nitrogen and oxygen. Okay. Now unknown compound contains 9 hydrogen. So if you see this integration and this integration and this integration, they are 100% same. It means if this is a signal of 2 hydrogen, this is a signal of 2 hydrogen, this is a signal of 2 hydrogen. So 2 hydrogen expansion is given over here. 1, 2, 3, 4, 5. We are getting 2 hydrogen pentate. Here we are getting expansion 2 hydrogen triplet. And here we are getting expansion is given 1, 2, 3, 2 hydrogen triplet. So 2 plus 2 plus 2, 6. We have 9 hydrogen. So 3 hydrogen are exchanged with D2O. So those hydrogen which are connected with heteroatom, they are exchanged with D2O. They will not appear on the spectrum. Okay. So how you will draw 2 proton pentates? So 2 proton, neighbor 2 and 2. So now this 2 proton signal, this 2 proton signal will give you a pentate. How you will get 2 proton triplet? So this signal, you can say this signal will give you a 2 proton triplet. This signal will give you a 2 proton triplet only when the environment of both this CH2 and CH2 is different. Okay, molecular formula of the compound contains 4 carbons. So it means this group is present, this fragment is present in this unknown compound. So let me write this fragment first of all over here. CH2, CH2, CH2. Okay. IR has confirmed this unknown compound contain carboxylic acid, C double bond OOH. And because carboxyl group always appear at the end of chain, so let's put carboxyl group on one side. Okay. Now, if you see the molecular formula of this unknown compound, we have 4 carbon. How many hydrogen? 2 plus 2 plus 2, 6, 7. 7 hydrogen means 2 hydrogen left. And how many oxygen? Oxygen done. So it means we have left 1 nitrogen and 2 hydrogen only. So simply connect 1 nitrogen and 2 hydrogen to this side only. So these are the 2 hydrogen. 3 hydrogen. 1 hydrogen is this one and 2 hydrogen are this one. These 3 hydrogen are exchanged with D2O. I told you whenever hydrogen is connected directly with heteroatom. Heteroatom include oxygen, nitrogen, sulfur. So these hydrogen are exchanged with D2O. So similar phenomena is going to take place over here. So these 3 hydrogen, these 3 proton will not appear in the spectrum. You can see. So now this is a 2 proton pentate. Its ppm is written. It's around about 1.9 ppm. What about this signal? CH2. This is about 2 proton triplet. It is appearing at 2 proton triplet. This 2 proton triplet is going to appear around about 2.2 ppm, 2.3 ppm. While this 2 proton triplet will appear at higher chemical shift because CH2 is directly connected with nitrogen. Nitrogen is a heteroatom. So it will appear around about 3.1 ppm. So that's the structure of this unknown compound. You have to write the formula again. And you have to write the carbon 13 NMR value on this spectrum. Okay, let me write the structure again. In carbon 13 NMR, CH2, C double bond OH, CH2, CH2, NH2. Okay, now simply because this compound contains carbon 13 only provide information about carbon. So we have 1, 2, 3, 4 carbon. So this carbon is this one. This carbon is this one. This carbon is appearing around about 160, 170, 180 ppm. You can write the ppm directly as well, 180 ppm. This carbon will appear around about 40 ppm. You can write 40 ppm. This carbon is this one. This carbon is going to appear around about, you can say, 32 ppm. And this carbon will appear around about 25 ppm. So this is way you will be able to solve a spectrum like this. So I hope you have enjoyed this discussion. See you in the next discussion. Wish you best of luck. Bye-bye.